Okay, now we have another question similar to previous one. When the both addends are missing or minuend and subtrahend is missing, and you have to find out the addends or missing numbers, but both the missing numbers. But here we have another situation. It is given in fractions. So there is not much difference as if you go through the problem, you will not find out the much difference over here. It is very much similar to the equation that we have solved, very simple one, a plus b is equals to 5. So here we have when sum of two like fractions, when there is already given like fractions, that means the denominator will be same for all the fractions. Okay, when sum of two like fractions is 13 upon 25, that means dash plus dash, means first fraction plus second fraction is equals to 13 upon 25, and the difference is 1 upon 25. That means minuend minus subtrahend, first number minus second number is equals to 1 upon 25. So find the two fractions. Here we have to find out two fractions which are missing. Okay, so we have same method as number composition. So, and we have seen these are the small numbers which we can, for which we can find out very easily. But if it is a big numbers, we have a variable method system which we will learn in grade 4. But this is a challenger question in WonderMath book for CBSE. So only one question is like that, where you have to find out this kind of fraction. So it's a challenge. Let's do it with number composition method, as we have learned how to compose the numbers from grade 1 onwards. So here we have, we need, see, denominators, as it is already given over here that there are two like fractions. That means denominators will be same. So we don't have to worry about the denominators. We will simply think about the numerators. Okay. So 13 and 1, we should get the answer 13 and 1 as the difference. Sum should be 13 and difference is the 1. Okay, so we will only think about sum and difference and only for numerators. Okay, because we know these are the like fractions, so all the denominators will be same. So for as of now, we will be thinking about only numerators, calculation of numerators. Okay, so number composition for numerators, we have first composition. If we want sum as 13, I'm trying first as a 0 plus 13 is equals to 13. But if I take these two addends in minuend and subtrahend, then I cannot subtract 13 from 0. So this condition is not applicable for this equation. So this will be not useful for us. So this condition is giving us false. So we'll move forward. We'll think about another number. Let's go 1 plus 12. So 1 plus 12 is also giving us answer 13, sum as 13. But 1 minus 12, it doesn't give us any difference because we cannot subtract 12 from 1. So again, it is not applicable. So wherever minuend is smaller from subtrahend, we cannot subtract unless and until we get minuend bigger and subtrahend smaller, so that we get a difference of 1. Okay. So again, 2 plus 11 is 13, but 2 minus 11 is not applicable. 3 plus 10 is 13, but 3 minus 10 is not applicable. So here we all have some which are giving us condition as true, but in difference, we are not getting this condition as a true. So I'll move forward. 4 plus 9 is equals to 13, but 4 minus 9 is not applicable. Same 5 plus 8 is 13. 5 minus 8 is not applicable. 6 plus 7, again, no. 6 plus 7 is 13, but 6 minus 7 is not applicable. Here we had got some finally the answer. 7 plus 6 is equals to 13. Yes, condition is true. And 7 minus 6 is equals to 1. Rest all the conditions that we got are not applicable in difference, because 8 plus 5 and 8 minus 5 is not giving us the it is not meeting our requirement. So we will not go further. I have written all these options, but there is no use of going further. Our condition has met over here. So we will be considering 7 and 6 is as the addend, and 7 and 6, 7 as minuend and 6 as subtrahend. So as we know, these are the like fractions. That means denominator will be 25. 7 upon 25 plus 6 upon 25 meets our requirement as 13 upon 25. And 7 upon 25 minus 6 upon 25 gives us 1 upon 25 as the answer.